Hello, I'm here to talk about a comment that I received on the first video of the channel. The comment was basically saying how for someone to niche down into a difficult subfield of computer science, such as machine learning or robotics, it would require the person to have studied computer science in university. And I'm here to disagree and to give tips on how anyone can learn a difficult subfield, not just within computer science, but in any subject, such as mathematics or, a different language. I, I think I think there is a daunting nature of computer science because I don't know if you guys have seen that meme, but there's like a glacier and then it has like the most popular fields of computer science on the top of the glacier, and then beneath it is like a huge, um, like the bigger part of the glacier is underneath the water, and that's like the vast realm of all the niches within computer science. So I get it. I get that it's pretty daunting and overwhelming because it was very overwhelming for me as well. But I'm here to kind of give tips on how to make it way more approachable, whether you're a CS student or not, whether you're like an English major making a complete like 180 degrees flip. So, to begin, I want to talk about a concept that Elon Musk talks about. There's something called first principles thinking. So, for first principles thinking, you're trying to think of the atoms of whatever thing you're trying to study. For example, for English, the atoms are um, characters, grammar, um, syntax, and the list goes on. These are the foundations of reading a text, at least in English, and probably all languages. For computer science, the atoms might be um, transistors, bits. The list goes on. There are things that are black boxed by programming languages and technology. But if you really get down to it, everything comes down to these smaller atoms within computer science. So, why do I say this? When I was first starting to learn programming, I was very heavy into web development using React. And even at that time, using React to me, this was in 2019, I want to say. It was very overwhelming because even with React and web development, there's React, then you have to kind of know about Node, the compute engine for, one of the most popular compute engines for JavaScript. Then you have to know NPM, the package management system, and the list goes on and on. And you finally get down to not the atom, but the core of React and using that framework for front end development, which is just a language, JavaScript. And learning React at that time and how to make really good websites, it was very difficult because university doesn't teach how to make good websites. I had to learn using Stack Overflow, YouTube, Reddit, a lot of tutorials. And I'm here to argue that even in any subfield that you'll choose to learn, it'll always be this overwhelming. There will be the actual thing that you want to learn, and then there will be a bunch of prerequisites that you need to learn. For example, if you look at um, machine learning has a lot of prerequisites, um, arguably a lot more than learning React for front end development. Um, you most likely need to know a good amount of probability theory, linear algebra, you should definitely know calculus, both single variable and multivariable. You need to know some optimization. You also need to know statistics because um, strategies like linear regression, KNN, random forest, these all kind of stem from advanced statistics. So, yeah, the list goes on and on and on. I mean, yeah, you also have to know Python, object oriented programming. You actually might have to know functional programming as well to write certain lambdas that you might have to write for NumPy. See, like even that, there's NumPy, there's the plotting library, matplotlib. Then you have to know PyTorch or TensorFlow. You might even run into scikit-learn. So it goes from very high level things, like entire fields of study, such as linear algebra, all the way down to the package level, like PyTorch, NumPy, Matplotlib. And then you go all the way down, you get to Python. And then from there, you go all the way down to these atoms, which are transistors, bits, and things being manipulated in the hardware of your computer. So I write this and I talk about this not to make it more overwhelming, but to show that any field of study will have a vast number of prerequisites, some more than others, but it's all a matter of time. If you can invest more time into something, you'll just keep knocking off all the prerequisites as you keep going. It's like when you're learning a new language. When I was learning Korean in high school, I wasn't very good at Korean growing up. So when I was learning Korean, I had to learn the characters, I had to learn how the grammar worked, I had to learn the syntax of sentences. And there is a prerequisite of learning new languages as well, in that it helps if you already know one language, at least, in my opinion, which a lot of us already do. But imagine you were fully conscious and a real human when you were a baby. Imagine you were a baby and you were thinking about learning a new language before you even knew a new language. I mean, before you even knew one language. You would probably be so overwhelmed that it would stunt your growth and you would never learn a language. But if we can just go back to that childlike wonder of being a baby and just learn, if we can just have that infant-like wonder of just learning to learn, learning how to walk, learning how to talk. It's not like the baby was like, oh, I've never even done this, how am I going to do it? They just learn it over time through nurture and care of their parents. But in this case, you're going to have to nurture yourself through learning, through textbooks, YouTube, find great creators that will inspire you to keep going. Yeah, let me see what else. Okay, to kind of wrap this up, I wanted to say, I'm gonna bring it back to the first example. Writing a JavaScript web application and doing some complex machine learning problem. They're fundamentally both very difficult things. A professional machine learning engineer probably cannot make as beautiful a website as a React god, a React legend. In the same way, a React legend most likely cannot find the optimal hyperparameters for some model because they lack the intuition that the machine learning engineer might have. And this is normal. No one can be an expert at everything. My first video was saying, become an expert at exactly one thing and just completely be sucked into that one thing. And from that one thing in this video, I'm saying that there are a list of many prerequisites that you will most likely have to learn. And instead of being overwhelmed by seeing the big glacier of it and how vast it is, I am arguing that you should be like a baby, learn from the small atomic bits of that field of study that you want to niche down in, and bubble it up to the grand picture of everything. So, again, I'm just going to take machine learning as an example because that's what I've kind of really niched down into over the years. Get some context of it first. Watch a cool YouTube video about machine learning. Go on x.com and read some posts about it. And once you've done that, once you have the motivation, create yourself a list of prerequisites that you think that you need in order to be a master of the field, or find people like myself on X or YouTube to give you these prerequisites. On my x.com account, I actually have a pinned post with a whiteboarding session of all the things I feel like people should learn in order to be a very solid software engineer and machine learning engineer. So you guys can check that out, or just create your own from your own research. But tackle everything one step at a time. Don't try to do 10 things at once. Do one thing, master it, move on to the next. So if you know Python very well, learn how to use NumPy. Learn how to write classes very well. Learn abstraction, these basic programming fundamentals. Then learn the mathematics. Learn traditional statistics. Learn how to write derivatives and the geometric intuition behind them. Learn the linear algebra, the geometric intuition behind matrices and their transformations on vectors and other matrices. And learn traditional machine learning. Then learn deep learning, and just keep going one step at a time, as if it's a video game. Okay, this is all I kind of have to say. I'm encouraging you guys. I know it's very overwhelming. It doesn't come easy, but know that there are people who have done it, like myself, and I truly have a passion for making this easier for everyone. Like, it's not just for computer science, it's just the philosophy of life. I want people to know that they can truly do anything if you just sit down, conquer your own thoughts, the negative ones, and just tackle at things one at a time, kind of like a trade. Kind of like if we were all sushi chef, we would learn steps 1, 2, 3, all the way until the last step in order to be a master sushi chef. Learning how to cook rice, how to get the perfect blend of it, learning how to shape the rice perfectly, etc. So yeah, that's all I have to say. I hope you guys got something out of this, and send me a DM on X if you want to learn more, or just leave a comment, and I'm here to help. Thank you.